Okay, I need to talk a little bit about other sorts of objects. If we were to repeat squares into perspective, let me get these out of the way here. I need new paper. What I'm going to do is show a method for repeating squares, rectangles, and even solid boxes in perspective. And we do that by one good way to do that is by drawing in any rectangle or square. If you draw from a corner through the halfway point on a square or rectangle, you can repeat its dimension. So let's see how that works. Tape this down here. What I would like to show here is just maybe some boxes for now. So a method then for repeating squares or rectangles. I'll do this. This will be for now. I haven't talked much about 2-point, but I'm going to draw this in a 2-point perspective. So I'm using a vanishing point here, and then coming down this way. At this point, I will draw a vertical corner of a box here. And I'm going to say the box is about that high. I'll draw to a vanishing point over here. So drawing to a vanishing point here. I'm going to draw boxes repeating, going off to the right vanishing point like this. So I'm going to say that this box is just an arbitrary depth. I'm going to make it this deep right here for now. And then over here on this side, just an arbitrary size here. And then drawing toward this vanishing point at the top of the box. What I would like to do is repeat this box going off toward the right. I'm going to make some noise here, just pencil sharpener. If I take this point right here on the box and measure it and divide that in half, say about right here, what I think I'll do is start off by drawing a line from the halfway point to the vanishing point like this. Now the thing that I want to communicate here, and I think maybe I need to show it in a diagram here. If I have a box like this, and I want to repeat this, what I said before, this is a square box in this case, I can take the halfway point on this side here, and I can, by drawing from a corner through the halfway point, I can repeat its dimensions, see, by drawing this way through the halfway point like this. That will give me another box the same size if I take it down like this and draw the bottom. So you see I have a method of repeating this. Drawing from a corner through the halfway point, little sparkly dots there, gives me the next box. Another thing I can do, I can find the halfway point on this box by making diagonals from corner to corner, and drawing through there a vertical like this gives me the halfway point. I also could do a line through here, gives me 4 half-size squares. So I can cut this in half, or I can extend it to twice its size. So let's do that here. I've measured this. These are equal in 1 point per, I'm sorry. These lines are parallel to the picture plane. They are not foreshortened. The verticals are in 2-point perspective are parallel to the picture plane. The horizontals are not parallel to the picture plane. We cannot measure those and divide them in half. But the verticals we can, because they have no foreshortening. So what I'm going to do here is use that halfway point and draw from a corner through the halfway point up to the top like that. What that gives me is the size of the next box. By drawing a vertical at that point, I can then draw to this vanishing point over here like this. I got a box the same size. I can also repeat it again by doing this. And then draw down this way. And draw to this vanishing point over here. I'll do one more. Drawing from a corner through the halfway point. You can see how I'm repeating each one of these units. And they're getting smaller and smaller as they are foreshortening into perspective. Okay? All right. there is, I think I maybe need to discuss a little bit about the idea of lines parallel to the picture plane. If you look at, let's see, I think I can sketch this here. If we see an intelligent student looking at a picture plane, this is my drawing of an intelligent student. Okay. Got glasses on. Okay. This is a student looking at a picture plane. Let's make it a guy. Okay, looking at a picture plane. So looking straight across here at a picture plane. So the picture plane that he's looking at is seen here. We're seeing it in perspective. So we're seeing it on edge, see, like this. Now, his eye is at the eye level, of course, and the eye level is the horizon line. Now, below that horizon, behind the picture plane, is a 1-point box. That means the box is parallel to the picture plane. So you see we have these lines going to the vanishing point like this. This 1-point box, the verticals and horizontals that face the picture plane are, of course, parallel to the picture plane. Therefore, they have no convergence when seen in perspective. So what this person is seeing can be represented like this. Here's the picture plane seen straight on. Here's the eye level of the person. It's up here like this. And below it, we see down here that box. Now see the lines that are parallel to the picture plane, the lines that are parallel to the picture plane, the horizontals and verticals on the front surface of that box do not converge to a vanishing point. But the lines that are not parallel to the picture plane, that is the lines going back in depth like this, these lines converge to a vanishing point. Okay? In 1-point perspective, the vanishing point is the center of vision. Now the back surface of this rectangle or square, let's say square, is parallel to the picture plane also. So those lines are parallel to each other and do not converge in the distance. So we have a person looking at a 1-point box that's behind the picture plane. But the lines that are parallel to the picture plane do not converge. Now what happens in 2-point perspective is, if I can erase this and convert it into a 2-point perspective, let's do this. Let's take this box away. Let's take away that vanishing point center of vision. Now let's see this person looking at a 2-point box behind the picture plane. This person sees a box where the certain horizontals are not parallel to the picture plane. Got to get this right here. Okay. So what we have here is a box where these lines are not converging to the 1-point vantage. Maybe move this just a little bit differently here. A little bit flatter like this maybe. Okay, what we have here then is a 2-point box behind the picture plane. Okay? So what the student sees there is the verticals are parallel to the picture plane, but the horizontals are not parallel to the picture plane. They go to 2 different vanishing points. So here's what this person is seeing here. It is now a 2-point box. So again, the verticals are parallel to the picture plane, but the horizontals are not. They're converging to vanishing points on the horizon line. Like this, like that. So what we know from this is lines parallel to the picture plane do not converge. We also know that lines not parallel to the picture plane converge to vanishing points. So there's one other example here that I should show maybe, and that is what happens in 3-point perspective. We're not really going to talk too much about 3-point today, but just to show you what that might look like. What happens in this case is you remember that the center line of vision or the distance line is always perpendicular to the picture plane. So if this student now is looking down, let's say he's looking down like this, Okay, he's looking down this way now. Remember that the center line of vision, is always perpendicular to the picture plane. So the picture plane he's seeing here would look like this. See, it's perpendicular. Where his center of vision is on the picture plane, and the distance line is perpendicular. But you have to realize this. The horizon is still up here at eye level. So what we have here is a center of vision that is not on the horizon line. It's below the horizon line. Okay, the student here is looking at a box that is behind the picture plane that is not in any way parallel to the picture plane. Nothing on this box is parallel to the picture plane. What that means is what is being seen here, and with the horizon line still up high, like this, the box that is being seen in this case is converging in three directions. No lines are parallel to the picture plane. These lines, the verticals are not parallel to the picture plane either. They're converging to a vanishing point below the horizon, and the horizontals are converging to vanishing points on the horizon. So what we have here is a situation where no lines are parallel to the picture plane in three-point perspective.